Imagine a peaceful afternoon. Suddenly the ground beneath you begins to shake. Buildings sway, windows shatter, and the earth rolls like ocean waves. Earthquakes can level cities and reshape landscapes in minutes. They remind us of the immense power beneath our feet. Our planet is a dynamic system, constantly in motion. Understanding earthquakes helps mitigate their effects. Join me as we explore the science behind these shakes. To understand earthquakes, we must first understand the Earth's structure. Beneath our feet lies a planet far more dynamic than it appears. The Earth is composed of three main layers: the crust, the mantle, and the core. Think of it like a giant layered cake, each layer with its own distinct properties. The crust is the outermost layer, a thin, rocky shell that we call home. Beneath that lies the mantle, a much thicker layer of hot, semi-solid rock that churns slowly over millions of years. And at the very heart of our planet lies the core, a dense ball of iron and nickel with temperatures hotter than the surface of the sun. But the Earth's story doesn't end there. The Earth's crust is not one solid piece, but is broken up into massive, jigsaw-like pieces called tectonic plates. These plates float on the semi-fluid mantle, constantly moving and interacting with each other. It's this movement, this constant dance of the tectonic plates, that gives rise to earthquakes. The Earth's tectonic plates are in perpetual motion, albeit incredibly slow. They drift apart, collide, slide past each other, or even one plate dives beneath another. These interactions are the driving force behind many of Earth's most dramatic geological features, including mountains, volcanoes, and of course, earthquakes. Imagine pushing two massive blocks of rock against each other. The pressure builds and builds until finally something has to give. This is similar to what happens at tectonic plate boundaries. As these massive slabs of Earth's crust grind against each other, immense pressure builds up over time. This pressure isn't always released gradually. Sometimes it's held in check for years, decades, even centuries, until finally the strain becomes too great. The rocks fracture and slip along fault lines, releasing a tremendous amount of energy in the form of seismic waves. These waves then ripple outward from the point of rupture, traveling through the Earth's interior and along its surface, causing the ground to shake violently. That, in essence, is an earthquake. The energy released during an earthquake travels in the form of seismic waves. Imagine throwing a pebble into a still pond. The ripples that spread out from the point of impact are like seismic waves radiating from the earthquake's epicenter. These waves are what cause the ground to shake and are classified into two main types: P waves and S waves. P waves, or primary waves, are the fastest type of seismic wave. They travel through the Earth's interior, compressing and expanding the rock as they pass through, much like sound waves move through the air. These are the waves that you would feel first during an earthquake, often as a sudden jolt or bump. S waves, or secondary waves, are slower than P waves and travel in a more side-to-side motion, causing the ground to shake horizontally. These waves are more destructive than P waves, as they cause more ground movement and can topple buildings. By studying the arrival times and patterns of these waves, scientists can learn a great deal about the earthquake's strength, location, and depth. Section 5. Echoes in Time, Stories of Earthquakes Past. The Earth bears the scars of countless earthquakes throughout history. The 1906 San Francisco earthquake reduced much of the city to rubble. Estimated at a magnitude of 7.9, it struck in the early morning hours. The ensuing fire destroyed nearly 80% of the city. The 2011 Tohoku earthquake and tsunami devastated coastal communities in Japan. With a magnitude of 9.0, it caused widespread destruction and claimed thousands of lives. These events remind us of the importance of preparing for earthquakes. Section 6. The Earth trembles again. Aftershocks and their fury. The ground stops shaking, the dust begins to settle, but the danger is far from over. Following a major earthquake, the Earth often releases a series of smaller tremors known as aftershocks. These aftershocks, while generally less powerful than the main earthquake, can still be incredibly destructive, toppling already weakened structures and hampering rescue efforts. Imagine a building already damaged by the initial earthquake. Its foundation is cracked, walls are crumbling, and it's teetering on the brink of collapse. Now imagine a series of aftershocks. each one delivering another blow to this already vulnerable structure. It's a recipe for disaster. Aftershocks occur because the Earth's crust is still adjusting to the massive displacement of rock caused by the main earthquake. They can continue for days, weeks, or even months after the initial event, adding to the devastation and hindering recovery. Their unpredictable nature makes them a constant threat, keeping communities on edge long after the initial tremor has subsided. Section 7. The Ring of Fire, a map of seismic fury. The Earth's tectonic plates are in constant motion, but some regions experience far more seismic activity than others. One such region is the infamous Ring of Fire, a zone of intense volcanic and earthquake activity that encircles the Pacific Ocean. This 40,000-kilometer or 25,000-mile horseshoe-shaped region is home to around 90% of the world's earthquakes and 75% of its active volcanoes. It's a place where tectonic plates collide and grind against each other, giving rise to frequent and often powerful seismic events. The Ring of Fire stretches from the southern tip of South America up along the western coast of North America, across the Aleutian Islands, down through Japan, the Philippines, Indonesia and New Zealand, before curving back around to Papua New Guinea. It is a testament to the Earth's raw power, a constant reminder of the forces that shape our planet. Section 8. Listening to the Earth whisper, predicting the unpredictable. Earthquakes are notoriously difficult to predict, but scientists aren't completely in the dark. By studying historical earthquake patterns, monitoring ground deformation, and analyzing changes in groundwater levels and gas emissions, they can identify areas at higher risk of experiencing a seismic event. One of the most important tools in their arsenal is the seismograph, an instrument that detects and records ground motion caused by seismic waves. These instruments are incredibly sensitive, capable of detecting even the slightest tremors, providing valuable data that helps scientists understand earthquake behavior. While we can't yet predict the exact time and location of an earthquake, these tools and techniques provide valuable insights into the Earth's behavior. They allow us to develop early warning systems, improve building codes, and educate communities at risk, ultimately mitigating the devastating impacts of earthquakes. Section 9. Bracing for the inevitable. Preparation and protection. Earthquakes are a fact of life in many parts of the world, but that doesn't mean we're powerless against them. By understanding the risks and taking appropriate precautions, we can significantly reduce their impact on our lives and communities. One crucial aspect of earthquake preparedness is building earthquake-resistant structures. This involves using robust materials, reinforcing foundations, and incorporating design features that allow buildings to sway with the movement of the ground, rather than collapsing under the stress. Equally important is having a plan. Every household in earthquake-prone areas should have an emergency kit containing essential supplies like water, food, first aid, and a flashlight. Knowing what to do during an earthquake, such as drop, cover, and hold on, can be the difference between life and death. Section 10. Living with a restless earth, a shared responsibility. Living in earthquake-prone areas requires a certain level of awareness, a constant acknowledgement that the ground beneath our feet can shift at any moment. It's about respecting the power of nature while taking proactive steps to mitigate the risks. This involves supporting research and development of new technologies for earthquake prediction and early warning systems. It means advocating for stricter building codes and investing in infrastructure that can withstand seismic activity. And it means fostering a culture of preparedness, where earthquake drills are commonplace and every individual knows how to respond when the ground starts to shake. Ultimately, it's about recognizing that we share this planet with forces far greater than ourselves. By understanding these forces, respecting their power, and preparing for their inevitable impact, we can create safer and more resilient communities in the face of natural disasters. Section 11. A final word respecting the power of nature. Earthquakes are a humbling reminder of our place in the grand scheme of things. They underscore the immense power of the natural world and the importance of living in harmony with our planet. While we may never be able to control these powerful forces, we can learn to coexist with them. Through scientific understanding, technological advancements, and a commitment to preparedness, we can mitigate the risks and build more resilient communities. The Earth will continue to tremble and shift, but with each earthquake we learn, we adapt, and we become better equipped to face the challenges of living on a dynamic and ever-changing planet.